Okay, so since both the gauge pressure and vacuum pressure is covered now, there are some numericals. Okay, so you need to do uh, from page number 44 to 46. You can solve in that book that I have given you. Okay, so you can also see this problem solving that is given in the YouTube itself. So how YouTube manometers problems is solved. So you just click on that and see how they solve it. So all things are given. So this is your task here. So there are certain numericals within the book. So I am giving the page number, so you can do those. These are already solved numericals, and please explore this. This will be helpful you to understand the concepts. So now moving on, so we are trying to find out the hydrostatic forces. Okay, so in the beginning we told you, right? So basically it was introduction. So fluid is subjected to hydrostatic forces. Sometimes it is pressure is kinematic pressure, sometimes it's dynamic. So in this unit we have to understand the hydrostatic forces. Okay, so and you have seen in hydrostatic forces the fluid is at rest, so there is no motion. Okay, so the liquid is not moving with relative to each other. Okay, so there is no relative motion, so that's why the velocity gradient is 0. So there is no movement, so there is no velocity, so there is the velocity gradient is 0. So that's why du by dy, so that is the velocity gradient that we have seen in unit 1. So that is equal to 0. So when there is no movement, there will be no shear stress. Okay, so when there is no shear stress, so shear stress will be equal to 0, because du by dy, so you know tau is equal to mu times del u du by dy. Okay, so if your du by dy is 0, and it will be 0. So this is your dynamic viscosity or just viscosity. Okay, so since the fluid is not moving, so your shear stress is also 0. So basically the forces that is acting on the fluid at rest is only due to the pressure above this. Okay, and then the weight of the fluid itself. So pressure that is acting normal to the surface. Okay, and the weight of that fluid. Okay, so what is the weight? So that is the only forces that is acting on a fluid particle when it is at rest. So there are two concepts here: total pressure and center of pressure. Okay, so total pressure is defined as like what is the force exerted by a fluid, or okay, that means we are talking about static fluid on the surface, either whether it's a plane surface or a curved surface. Okay, we have to see if a certain object is put, okay, if a certain object is put inside or immersed inside a liquid or water, so how the pressure acts on that. Okay, maybe a static fluid is there and you put some immerse, like if you immerse a ball, if you immerse a wood, if you immerse certain block of wood inside, how that static fluid causes or changes the pressure. Okay, how the pressure will act on this surface. So those forces will always act normal. Okay, so on to the surface, so that force is known as your total pressure. And then at what point this all net force that is acted on that surface. Okay, so what is the net point? Okay, since it is acting all the point, but where is the point of application? Okay, so that point of application is known as your center of pressure. So basically center of pressure is basically at what particular depth the force is exerted. So that is your center of pressure. Total pressure is usually given by force here, and center of pressure is usually given by the height. Okay, so what is the force? That is the total force, total pressure. And what is the center of height? At what point that force is acting? So that is your center of pressure. So here we will see in 3 or 4 different cases. Like first one, we will see in how the total force and center of pressure behave for the vertical plane surface. Okay, for the second case we'll see for horizontal plane surface, third case we'll see for inclined, and fourth we see for the curved surfaces. So these are all the surfaces that we will immerse or submerge into the liquid, and how the forces will act and how are their center of pressure moving up. Okay, so that we will see.